knowledge is applied.
Hello and good morning. This video presentation is a presentation about the advanced reactor technology found in environmental industries, specifically in wastewater treatment industries. Firstly, what is a reactor? Okay, basically, a reactor is a container or apparatus in which substances are made to react chemically, especially one in an industrial plant. Reactors have been invented during the 18th century. Until today, many different kinds of reactors were used worldwide. One of the advanced reactor technology used in wastewater treatment industries is anaerobic sequencing batch reactor, or ASBR in short. What actually is ASBR? Stay tuned and happy watching.
Anaerobic organisms were first discovered in 1861 by Louis Pasteur during his research on fermentation process. The utilization of anaerobic microorganisms in waste treatment started in 1881 with the development of Morris automatic scavenger. In its early application, anaerobic treatment was applied mainly in the sludge digestion. Also, early research on anaerobic treatment was focused on sludge digestion. In 1881, first conventional of anaerobic digester was used to liquidify the solid components of sewage. On 1891, the first septic tank is used to retain solids in sewage. 1905, development of the Imhoff tank in Germany. 1930s, the digesters were started to be mixed and heated to improve the digestion of solids in the sewage. On 1955, anaerobic contact process was developed to treat soluble organics and dilute wastewaters. On 2007, anaerobic sequencing batch reactor (ASBR) is known as a newly developed technology and has been extensively studied due to its advantages, such as no short circuit, as in the case of fixed bed continuous system, high efficiency for both COD removal and gas production, no primary and secondary settles, and flexible control.
So, anaerobic sequencing batch reactor, or as known as ASBR, is a system that is in the sequencing batch reactor, which is adopted in a total process instead of NOC or aerated step. Obviously, this is because it has anaerobic condition in those two steps. Yeah, she's right. Besides that, in ASBR system, there is not much different from sequencing batch reactor because ASBR is developed to complement the disadvantages of SBR system. So, Jude, tell them, what's the process of the ASBR system? Sure. There are 5 total processes in ASBR, which is fill, react, settle, discharge, and idle.
So let's get started with the fill phase. Wastewater is fed at a low rate until the tank is full. Typically, ASBR is operated in a zero-order kinetics.
Next is react phase. This is the main period when biodegradation takes place. Mixing is provided to ensure sufficient contact of the microorganisms with the substrate. During this phase, some microorganisms will die because of the lack of food. This will help to reduce the volume of settling sludge. The third phase is settle phase. Solid-liquid separation is allowed to take place by gravitational force. There is no liquid enter or leave the tank. This is to avoid turbulence in the supernactant. The fourth phase is discharge phase. The treated effluent is withdrawn from the system from the above of the sludge blanket. It is usually done at a slow rate to minimize disturbance of the settled solids.
This is the animation of how the anaerobic sequencing batch reactor works.
not least, is the idle phase. Idle phase is an optional phase which may or may not be incorporated into a system. So that's all.
This is the process flow diagram of ASBR.
Every reactor has its own advantages. Same goes as anaerobic sequencing batch reactor. The first advantages of anaerobic sequencing batch reactor is lower production of biomass per unit of organics removed. The second advantage is no aeration required. Aeration means by the process which air is circulated through, mixed with or dissolved in a liquid or substance. The third advantages is lower requirement for inorganic materials such as phosphorus and nitrogen due to lower biomass yield. The fourth advantages is anaerobic system can be left dormant without feeding for extended periods without severe deterioration in biomass properties. This means that they can be brought back into service at normal treatment efficiency within every short period of time. The fifth advantage is using anaerobic sequencing batch reactor, very high active biomass densities up to 1% to 3% can be achieved under favorable conditions. This means that volumetric reaction times can be increased, reactor size decreased, and the system's resistance to shock, loadings, and toxic compounds can be strengthened.
The conclusion is ASBR is almost the same as SBR. The difference is that ASBR has anaerobic condition in the system and is developed to complement the disadvantage of SBR system.